that the go-to statement was considered harmful. And nobody could believe anybody would be crazy enough to say that the go-to was a bad thing. Because that's how you wrote software in 1968, was with a go-to. That's how Fortran worked. That's how they all worked. And Edgar Dijkstra was bold enough to say that maybe that's a bad idea. So in the same way that Java isn't a non-go-to language, because we've just completely covered that over with an abstraction style, Java isn't a statement-oriented language, and Java isn't an object-oriented language. Java is a framework-oriented language. When was the last time you downloaded a single class file from the internet and used it for something? You never do that. You always download a library or a framework. That is the reuse mechanism that we use in Java, or frameworks, not just classes. Java is a structured language, and it's also a non-go-to language, and it's also an object-oriented language, but that's not the most important characteristic of Java anymore. It is that it's a framework-oriented language. And let's investigate that a little bit. Let's solve a problem. And here's the problem I want to solve. Let's say that we're talking to some sort of mainframe computer that produces a file that looks like this, where the first 4 characters are the kind of thing it is, and then the rest of the fields are fixed length fields that the first 4 digits determine what kind of thing it is. So the first 3 are actually service calls, SVCL. The 4th one is usage. So what we want to do is write some Java code that can parse this file that comes from a mainframe so that we can interpret this and create Java classes for server call and usage, etc. So how do we do that? Well, the most reasonable way to do that would be to use the strategy design pattern. So you create something called a reader strategy that has a get code method. It lets you define a field extractor, which says that the name field starts from character 4 and goes through character 18, etc. And then you write a whole bunch of code to make that work. Now, I don't really care about this code, but this works, but who cares? This is the code I really care about. Because once you've created all this code, now you need to actually define your strategies. You're going to write some code like this to do that, where the first one is configure service call, where you say reader strategy, you get the first SVCL, and then from 4 to 18 is customer name, and 19 to 23 is customer ID. And the second one is to get usage. What you've done is created a way so that when they add new codes to the mainframe stuff that comes out, it's easy. You just create another strategy, and you can read that stuff based on that first 4-digit character. What we have just done is something that is extraordinarily common in the Java world. We have created a framework, and then we have created a way to configure that framework. We do this all the time in the Java world. This combination of framework plus configuration, what a radical idea. What a unique way to solve a problem. And of course in Java, we're overrun with frameworks to solve all kinds of different problems. Everybody here, the project you're on right now, has probably at least a half a dozen frameworks, from the really complicated like Spring to the really simple like Log4j. Everybody uses frameworks all over the Java world. In fact, so much so that you might even say that we are in a framework renaissance in the Java world. But there's a little bit of a problem with this. Because as we build more and more frameworks to do more and more work, they start getting really complicated. Now, what happens in software when our abstractions get too complicated? We do what we've always done. We pave it over with a simpler abstraction. So what are we going to pave over frameworks with? We're going to do that with domain-specific languages. And this is a really old idea. In fact, domain-specific languages have been written since the Lisp days. So back in the late 50s, people were writing domain-specific languages. And it's one of those ideas that has been around for a long time, but we're just now really starting to pick up on it. In very much the same way that objects came about. So let's take a short trip in a time machine. Does anybody recognize this code? Anybody know what this is? I hear a guess of Pascal, and that's, you're in the ballpark. It looks very Pascal-like, but it's actually not Pascal. This is, in fact, the first ever object-oriented language. Now, a lot of people think that Smalltalk was the very first object-oriented language, but it's not. What I was just showing you is a language called Simula, which came out in 1967. So the first object-oriented language came out in 1967, and it was 13 years before we finally realized, hey, that's a really good idea. You'd think that something as clever as object-oriented programming, as soon as it came out, people would go, oh yeah, that's clearly the thing we need to do. And yet it took 13 years for it to even gain any notice whatsoever when Smalltalk 80 came out. And then more years until C++ became popular, and then Java, etc. Part of the problem we have in software is we always assume that the more interesting stuff is in front of us and not behind us. Because the guys who were writing Lisp, wasn't the IDE for Lisp bearskins and rocks and chisels? It turns out that it wasn't. There's some really good ideas that the Lisp guys had that we can take advantage of now. So what kind of neoclassical idea can we borrow from the past and recast now that we have better tools to use it? And that's where domain-specific languages come in. They've been around for a really long time, but now our tools have gotten to the point where it's easier to write them, and we have a compelling need to write them now because the abstractions that we're dealing with on a daily basis are getting more and more complicated. We're going to use DSLs to pave over that complexity. And here's an example of that kind of complexity. Java, being an object-oriented language, tries to organize things in tree-shaped hierarchies. Because that's the way object-oriented languages work. Everything goes into a tree-shaped hierarchy. But while this covers most of the kinds of things we need to model, there are a few things that this can't really handle well. Things like logging, or security, or transactions. And so what do? We add on to this aspects, cross-cutting concerns to make it easier to do this stuff. But the problem with that, of course, is that it makes it more complicated to actually get stuff done. And so what we're going to do is use DSLs to pave over that abstraction and make it easier to deal with again. Objects, aspects, and generics become the building blocks for domain-specific languages, meaning that this is an evolutionary step, not a revolutionary step. This is not as big a move as the move from structured programming to object orientation. What we're doing is using object orientation as the building blocks to build the next level of abstraction. So why would we use language as an abstraction? Well, there are some really compelling reasons to use language as an abstraction. And it's mostly revolving around this: jargon or slang, or the way that you talk to other people. Now this jargon may be a little iffy here. We'll see. I haven't actually seen one of these here, but surely there's one somewhere. Does anybody know what this is the jargon for? Starbucks. This is the Starbucks jargon. This is how you order coffee at Starbucks. If you've ever been to Starbucks and ordered a few coffees, you recognize this instantly. Now this next one, there's not a chance in the world anybody here is going to recognize this next one. I'll be really surprised if you do. It will mean that you've been to the States and probably to the southern part of the United States. Does anybody recognize this jargon?